If you've done any work with a large language model, one of the first things that becomes clear is how the results vary a great deal across runs, and that's even when you supply the exact same input every time. Now in theory, this is a feature, not a bug, but when it comes to testing these systems or applying them in real-world ways, we often want the same results from the same inputs. The technical term for this is determinism. And one of the toughest things about LLMs is how surprisingly hard it is to get real determinism, especially with an LLM that's deployed at scale on someone else's hardware. Let's start with some basics as to why this is the case. Now, in theory, a large language model is deterministic. It's a mathematical model where you get certain outputs for certain inputs. But for many applications like a chatbot, you don't want the exact same results each time. You want variety. You want something that resembles human conversation. So to get that kind of variety, a couple of parameters get used by LLMs to introduce randomness into their system. And one of them is called temperature. The lower the temperature, the less synthetic randomness gets added to the outputs. So in theory, a temperature of 0 would return the same results each time. This also goes for the seed, or the parameter used to initialize how randomness is generated in the system. If you set the same seed, in theory you get the same random sequences. So again, there's these two words that are doing a lot of heavy lifting there. In theory. The practice is a lot more complicated. First off, LLMs tend to be really big, billions of parameters. And so to make them manageable, they're encoded using certain tricks in math that introduce imprecisions along the way. These imprecisions add up. Anyone who's worked with floating point numbers in computing has some idea of what this is all about. So a certain randomness tends to creep into the system whether you like it or not, just because of the way things are constructed. Another issue is one that manifests at the hardware level, and especially at scale. Running an LLM on a system distributed across many nodes makes it difficult to guarantee things will be processed in exactly the same order across all of those nodes every single time. And that's especially true in an environment designed to satisfy lots of different requests from lots of different people at once. And it's further compounded by all of the math issues that I just mentioned. Things arriving in different order necessarily generate different results. And then there's all of the other ways that indeterminacy can slip under the door. Let's say you have a chatbot that works with search engines to augment its results. I was actually testing something like this out the other day. I'll link to it down below. Well, guess what? By doing this, by bringing in results from the outside, you've just introduced a whole new dimension of indeterminism when you don't even really have that much control over, if any. So one thing becomes very clear from this. The bigger the model, the more users you have for it, the more you need to distribute the workload, the harder it's going to be to guarantee determinism across that system. So if you're building a solution that you want to be heavily deterministic, you have a couple of options. Unfortunately, neither of them are very good right now. One, you sacrifice some performance or scale to ensure that things can happen in a guaranteed order. Or two, you reduce your expectations for how much determinism you can really expect. Now, given how fast-moving this field is, I wouldn't be surprised if we soon see some mechanisms for better guaranteeing determinism in LLMs at scale. But for now, it's best to remember indeterminism is baked into the way LLMs work on many different levels. And that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.